In this video, we're going to go over the mask scoring RCNN paper. To illustrate the motivation of this article, the abstract starts with this sentence. Letting a deep network be aware of its quality of its own predictions is an interesting yet unimportant problem. They mention that in the instance segmentation problems, oftentimes the confidence of instance classification is used as the mask quality score. However, the accurate definition of the quality of a mask is defined as the intersection over union between the instance mask and its ground truth, which is not usually correlated with the classification score. In this work, Mask Scoring RCNN, they have focused on this problem. They have introduced a network block that learns the quality of the predicted instance masks. It takes instance feature and it also takes the corresponding predicted mask together, and it regresses the mask IOU. In other words, the quality of the predicted instance mask. As for the advantages, it calibrates the misalignment between mask quality and mask score. And it also improves the instance segmentation performance because it prioritizes more accurate mask predictions. And it helps improving the results. The focus of this paper is on the problem of instance segmentation, and they have proposed a novel method to score the instance segmentations. They mentioned that in most cases, instance segmentation is associated with the score of the instance mask, which is shared with the box-level classification confidence. To understand this better, please note that if you take an image in consideration, an object within that image has a bounding box. So there are three things that you have to predict in an instance segmentation pipeline, or three components that most of the pipelines include. Regressing the bounding box, classifying the bounding box to one of the C categories, or possibly the background, and third, to generate the binary mask of the instance. Now, the classification confidence for the bounding box is not necessarily correlated with how accurate the mask how accurately the mask fits the instance within this bounding box. In this work, they aim to obtain more accurate instance localizations. Therefore, they focused on scoring the masks. Their model learns a score for each mask instead of using the classification confidence as its score. And they call this the learned mask score. As it was mentioned in the beginning of this work, their main point of focus is that the classification score is not necessarily related to the quality of the mask. For instance, you can look at the first 4 pictures from the left on figure 1. As you can see, the mask RCNN score for them is very high. It's 1 or very close to 1. However, even though the class is correct, the masks are inaccurate. You can see that the head of the cat is missing. You can see that the hand of the guy is misclassified, and other instances. The last picture shows that their model, namely mask scoring RCNN, retains the high scores when it actually is classified nicely and the mask is good. However, in other cases, meaning the other 4, it actually has recognized that even though the classification is correct, the mask is not necessarily perfect. In this paper, the definition of mask IOU is the IOU between the mask of the instance and the ground truth of the instance. Once the mask IOU is obtained, the mask score is re-evaluated by multiplying this predicted mask IOU by the classification score. The idea is to compare the predicted mask and the ROI feature, which are both the things that this mask IOU head that they add to the system take. So it takes the output of the mask and it takes the ROI features. And it is trained using a simple regression loss. And the idea here is this. It explores a new direction for improving the performance of instance segmentation models. By considering the completeness of instance mask, the score of instance mask can be penalized if it has high classification score while the mask is not good enough. And they showed that it leads to consistent improvements. This part go over the related works to the object detection and instance segmentation. And again, the key limitation that they're trying to address is the fact that the quality of the predicted masks are often associated with the classification score, which is not a good enough measure. There have been several works prior to this in the literature that focused on correcting the outputs. There is the fitness non-maximal suppression that corrects the detection score using the IOU between the bounding boxes and the ground truth. The difference between their work and this work is that, first of all, they focus on bounding boxes while this work focuses on instance masks. And the second is that they formulated this problem as a classification. However, in this work, this formulation is as a regression task. There have been other works such as IOU-net, which regressed box IOU directly, and some other works. But again, the main difference is that this method is designed for instance segmentation level inferences. By doing some experiments to compare the mask scoring RCNN and mask RCNN, they have outputted this figure 2 here, which shows the limitation of the mask RCNN in basically in performing an accurate assessment of the mask qualities. Looking at this part, you can see that there are many examples in which the actual mask IOU is low, however, it is outputted a high score. However, in transitioning to the mask scoring RCNN, you can see that high score actually means high mask IOU. Therefore, the quality of the instance masks are now also considered. As another motivation, one can note that in many practical applications, it is also important to determine whether or not detection results can be trusted, which again has to do with the quality of the masks. Conceptually, mask scoring RCNN is basically mask RCNN with an additional head called the mask IOU head. They take the mask RCNN pipeline as described here, and to transition to mask scoring, they define the S mask as the score of the predicted mask, with the ideal value of S max being the pixel level IOU between the predicted mask and its matched ground truth. They want the ideal S max to also only have positive value for ground truth category and 0 for other classes. Therefore, there are two things that they have to handle: classifying the mask to the right category and then regressing the proposal's mask IOU. So they define this mask score as this. The goal of S-class is to classify the proposal belonging to which one of the classes within the set of categories. And it is regression of IOU which is the target of this paper, which is predicted using the mask IOU head, which uses the concatenation of the features from a region of interest aligned layer and the predicted mask as the input of the mask IOU head. They use a max pooling layer with a kernel size of 2 and a stride of 2, and then they make the predicted mask to have the same spatial dimensions as the ROI feature. And they do this regression only for the ground truth class. The mask IOU head has 4 convolutional layers and 3 fully connected ones. The IOU between the proposal box and the matched ground truth box has to be larger than 0.5 in order for it to be considered a positive example. Let's look at the pipeline here. This part is identical to the figure 3 of the mask RCNN paper, namely the one with the ResNet backend. Now, ROI aligned and bilinear interpolation have been used, and you have this 7x7 by 256 feature map for each one of the instances, meaning the detected boxes, and then you use it and you obtain the classification and the box regression error. Now this time, you take this 14 by 14 by 256 and you do the normal mask RCNN pipeline, and you get to this mask of 28 by 28 by 1. Now the idea here is that, as we mentioned, and as it was mentioned in one of the earlier sections, the 28 by 28 by 1 result, which is the predicted mask, will go through a max pooling in order to be basically 14 by 14 by 1. This max pooling was basically a kernel size of 2 and a stride of 2. And then here you would have like a 14 by 14 256. This was the input features. Now these would be concatenated and you would get this. Now from this, here is where the mask IOU head comes in, and mixed predictions regarding the intersection, or basically intersection over union of the predicted mask and the ground truth mask for that instance. Results on COCO 2017 validation set indicates that it has positive impacts. Now let's go over the design choices of input of mask IOU head. One idea is that the target mask concatenates the ROI feature. The other option is to multiply it. The other option is to consider all the C classes masks and concatenate with the ROI feature. The other option is to consider the high resolution ROI feature, consider only the target mask, or consider only the ROI feature. And according to the empirical results of Table 4, they chose what they chose, which was basically the concatenation of the ROI feature and the mask prediction for the proper category. There are also design choices with respect to what to regress. So one option is to basically focus on the mask IOU of the target category. The other option is to focus on basically all the positive instances, meaning that if another category also has a segment in the actual detected bounding box for the instance, you also have to consider the quality of that. And the other part is basically considering every classes, and those that do not appear, the model has to regress to 0. And again, you can see that the option that they eventually chose, they eventually had chosen, was the one that corresponded to the best performance. Thank you for listening to this review of the mask scoring RCNN.